So we talked about your standard normal curve. It's symmetrical, right? All these pieces add up to 100%. And I gave you this here. It's probably a little bit more detailed on your chart, the one from Algebra 2. Now, in statistics, we kind of estimate these a little bit. If you notice on your chart, this would come out to be 19.1 and 19.1, and then 15 and 15. This all comes out to be 68.2 in yours. In ours, we just say 68. So plus or minus one standard deviation is approximately 68% of your data. Think about building that mound of sand. Well, most of your sand is going in the middle, and then a little bit on the side and a little bit less on the bottom. So most of your things live right here in the middle. As you come out to plus or minus 2, we say it's approximately 95% of your data is covered here. And plus or minus 3, God bless you, gives us 99.7%. Notice the little bitty tiny pieces over here. They're just little teeny tiny pieces. We also notice that the book says anything at 2 standard deviations, above 2 standard deviations, is considered unusual. Anything above 3 standard deviations is very unusual, or below 3 standard deviations. Because look how small that percent is. You probably get a better view of it in, it's 0.1%. It's about 0.1%. That's how small that little piece is. So if it's going to be lower than 3 or above 3, it's going to be very unusual that that occurs. We still can get standard deviations that come way out here, because as we develop this a little bit more, we're going to see that this curve actually never ends. It's kind of like an asymptote, you know, the asymptote effect, where your line comes along the asymptote but never touches it. Well, no, this will just keep going out like this. It kind of just doesn't end, but it just like slims down to like minuscule, you know. But for our goal, we want to know where our percentages lie. So let's come up with another scenario. Say I give a test, and the mean on my test is 75, with a standard deviation of 5. Well, I just said one class, not both classes. So I want to know where, between what 2 numbers most of my data lies, where kids are scoring, consider that they've scored a normal curve. So how we work this is, again, like yesterday, your mean goes in the middle. The easiest way to work this curve is to put your standard deviations out right on the curve. On the chart that I gave you, notice you have it's divided by 0.5. Darken the 1 lines. This is what I was talking about. Darken it at the whole number. Bless you. God bless you. Because we don't want to go between them. We want to stay at the 1, at the 2. Because we only need to stay right here. So darken those lines. Now, you're going to add your standard deviation as you go up. You're going to subtract your standard deviation as you go down.
Right there?
Yeah. Well, this is just a good, so that you understand how this is working. Because today we're going to put a little bit of a curve in here. So just so that we're all on the same page. The test I gave, the results represented a normal curve. I had an equal amount under 75, an equal amount over 75. It estimated a normal curve. Normally my tests don't, because you're college level students. So normally my curve is a little skewed to the higher end, because you usually do better than some doing real well and some doing really poorly. Usually you guys do better overall, because you're college level. In a heterogeneous class of a mixture of everybody, it would pretty much follow a normal curve. SATs follow a normal curve. So I want to know between what two scores did 68% of my students fall between the plus or minus 1? Now I know, because I labeled them out there. Could I also say my mean plus 1 standard deviation, 75 plus 5? My mean minus 1 standard deviation, 75 minus 5? Absolutely. I can take 1 standard deviation above, 1 standard deviation below. Me, I like to put all my numbers out here. And I'll tell you why. For a score that falls below 75, you kind of get a feel, whoops, this has a negative, well, we'll call this Z-scores. It's going to have a negative score out here, a negative 3, a negative 2, a negative 1. The 0 is in the middle, and the positives are on the right. So we could see that it's going to fall to the left of the mean. It's going to have a negative Z-score. It's going to fall to the right of the mean. It's standard deviation score, kind of, if you will. And it will have a positive if it falls to the right. Mostly through this course, I have you sketch. Because I need you to realize where your negatives are, where your positives are, so that you know where everything has a perspective, some kind of a relationship here. So does everybody see why we label this? And it makes sense to do this? So now I can say, okay, what percent of my students scored greater than 80? What percent of my students scored better than 80? How would you find that? Okay, then look forward. And what are you going to do to these percents? Add those percents up. Now you have your chart in front of you. So where 80 falls at the 1, you're going to add all the percents to the right of it. And that's how many did better than an 80 on the test. I'm just playing with your curve a little bit. You have the chart in front of you. This down here, your chart is kind of broken out a lot better than this one is. That's like 0.1 out there.
This one out of the
This is 0.1 out here. Question? Any question?
There's different percentages.
Well, it's just that we rounded a little bit differently. Yours is divided by 0.5. So yours says 19.1 and 15. If you add that together, that's 34.1. Yeah, yours is divided by 0.5. So I said, make a dark line at the ones. And you'll be the same as mine. This I took from your Algebra 2 regions. This I just took from the book. It's the same chart. Right, but look at the bottom. Yours was divided by 0.5. So all of these have 0.5s in them. 1.5. See it? Yours was just divided into 0.5. The total percentage is still 100. So we add up these percents, and you can tell me what percentage of students scored above an 80 on your test. What percentage of students scored between 65 and 85? How would I find that?
The percentage.
Add the 68 plus, not 95. Well, it turns out to be 95 because it's plus or minus 2. But you could add this, plus this, plus this, plus this, and you'll get 95%. We are just a little teensy off from the algebra because the algebra was a little bit more exact than we are in statistics. We round. Instead of 68.2, we just say 68. Instead of 95.4, we say 95. So we have a little bit of a rounding, but it doesn't really matter. You can use that chart as well. Okay? All right. Now, moving right along, sometimes you don't have a normal curve. Sometimes your curve is skewed, but you don't know where it goes. So we have a theorem called Chebyshev's theorem. And Chebyshev says if you use this formula, you can approximate the percentage of where your data lies. You're going to find out where your standard deviation is first, and then you're going to put your standard deviation into here. This is where we slide our standard deviation in. Basically, Chevy Check can only do a standard deviation of plus or minus 2 or plus or minus 3. If we did a plus or minus 1, and I squared the 1, 1 divided by 1 is 1. 1 minus 1 is 0. So because we don't know anything about where the curve is skewed, we just know that it is not normal, using this theorem approximates for us. And this is the only time we talk about a non-normal curve in this whole course. So this is the only time you will see us use it. The rest of the time, this course refers to the normal standard curve. This in itself is a course in itself because you have to figure out where your skew is, where your area under your curve is always going to be equal to 1 or 100%. But you have to kind of figure out where the...
So they would give you the standard deviation. It looks like some...
No, you're going to find your standard deviation and you're going to plug that in for K. You're going to pretend it's normal. You're going to find your standard deviation, but then you're going to use his formula. And he can only do in his formula a plus or minus 2 or plus or minus 3. So he kind of approximates. If you kind of take a look at this, plus or minus 2 is about 75% of your data. Plus or minus 3 is almost 89% of your data. That's as close as he can go. You know how we added up all the percents? This is the only two things that it's going to return from Chebyshev's theorem for our purposes. Because we just want to know, okay, so what if it's not a normal curve? What do we do? Well, we can't use the percentages on our normal curve because it's not going to look like that. However, we don't exactly know where is this curve skewed, what's the slope of it, how drastic is it. So he has an approximate way to figure out 75 or about 89% of the data. So let's take a look at his and see what we mean. So I'm on example 7, on page 89. He gives you two charts. Now, see his graphs that he gives you? Do they look like they follow a normal curve? No? So his graph for New York kind of looks like this. It kind of has like a bunch of big bars here. And then it kind of just trails off a little bit. So where's the skew? To the right. It's skewed to the right. So does it follow a normal curve? No. So this has a skew. If anything has a skew, we're going to follow Chebyshev's theorem. However, we have a little bit of a twist in here. He says, okay, this time he told us, the age distribution for New York and Alaska are shown. Apply Chebyshev's theorem to the data for New York using K equals 2. So he has a standard deviation, 2 units, 2 standard deviations away from his mean. So we're going to use his formula. His formula says this, and you're going to have to memorize this. It's not a hard one. So 1 minus 1 over k squared, this is where the k goes. 1 minus 1 over 2 squared gives you 1 minus 1/4, gives you 3/4, or 75%. Remember we said it's either going to be 75% or an 88.9%. So we know that 75% of his data is going to fall between plus or minus 2. Now, in order for us to find the actual ages it's going to fall between, we have to go back to the normal curve. So we don't know where this age falls. So we could do one of two things. We can take this guy and add 2 standard deviations, and take this guy and subtract 2 standard deviations. So you're going to take 38.8 and you're going to add 2 times 22.5. You see what I'm doing? We have to kind of use the normal curve rule just to figure out where his ages are. Then you're going to take 38.8 and subtract 22 times 25.5. So, here's the problem. These are ages, right?
Where'd you get,
Where did the 20 come from?
where did 2 come from again?
What?
The K, right?
The 2,
Is that
the
22?
2, is K is 2.
That's 20.
2 is 2 standard deviations away from the mean.
Alright.
So this is more,
75% of this data is going to fall between the two numbers we come up with. Yes.
so whatever the K is, you multiply it by the standard deviation and add it to the.
Yes. Because right now we know it's going to be 75% fall 2 standard deviations away from the mean. But we don't know what those values are yet. So the same way we do your curve, we put the mean here. What's the mean? 38.8. And 1, 2. We add 22.5. We add 22.5. We subtract. We subtract. You could do it right on there as well. It's either going to be a 2 or a 3.
Well,
So,
what's that beside the 2? Beneath the plus sign.
Like, I don't understand.
That's a minus.
Go down.
Is that a minus?
minus 2 standard deviations.
Oh.
It got my pen kind of dragged.
You have to add to that one and minus that one, or is it either way?
Okay, let's go back to your graph. Let's put your mean right here. You have to try to pretend it's a normal curve. What did we do before? We took 38.8 and we added 22.5, your standard deviation. This became 61.3. Then we did it again. This became 83.8. Then we did it again. This is 106.3. Then we subtracted on the way down, right? So we started with 38.8. We subtracted 22.5. 16.3. Subtract again 22.5. And you get negative 6.2. Okay? So, 75% of our data is falling 2 standard deviations away from the mean. So the ages will go from negative 6.2 to 83.8. Can we ever have a negative 6.2 age? So we're going to say from 0 to 83.8 is approximately covers 75% of the data. This is what we came up with. We have to have a way to find his ages for plus or minus 2. So we kind of use the concept of add 2 standard deviations above the mean, subtract 2 standard deviations below the mean. Look at your chart, guys. Look at your chart. This is not a normal curve. However, we just use the normal curve just to figure out where would the ages fall if it were normal. That's why I kind of like not to use it here. I like to just use the formula here because it would make more sense. Yes.
No, go
Yeah, wait. Go either at the beginning. Yeah, go either at the beginning or at the end. Yes.
So, I don't get why it stops at 83.8. Where did that number? Why not 100?
Because it's 2 standard deviations
Oh,
above the
it's
mean.
two?
See this
Two
K equals 2?
Okay.
He wants us to go 2 standard deviations away from his mean.
So technically, you didn't need to get all the other ones. You just just to show.
Well, technically, all I have to do was this.
Take that.
38 plus 0.8 plus 2 standard deviations, 38.8 minus 2 standard deviations. That will give me the age it's to and from. I'm only going to go 2 standard deviations above the mean and below, or 3. Here's the problem though, this is not a normal curve. So technically, we would do a normal curve like this, and we would say, oh, plus or minus 2 standard deviations is 95% of your data. But the problem is, it doesn't fit a normal curve.
So we had to do that thing.
So we have to use his formula to figure out approximately what percent is between plus or minus 2 standard deviations. And then secondly, we had to get the values of those plus or minus 2 standard deviations. So we could either do it this way, or you could put it on a graph just to get the numbers there. Just remember, you're not using your normal curve values, your percentages. You're using Chebyshev's percentages. Okay, let's try another one together. This is tricky. I told you this would be tricky. Okay, here's another one. Here's Alaska. Look at Alaska's chart. That's why you guys need to be paying attention. Alaska has the same problem. Is this a normal curve?
No.
Where's Stu? To the right. So this is not a normal curve. Now, they gave us the means in your chart, and they gave us the standard deviation. So they asked, apply Chebyshev theorem to the data for Alaska using k equals 2. They want you to look at their things. They want you to subtract 2 standard deviations from the mean. They want you to add 2 standard deviations to the mean. Okay, same as we just did. And then they want you to apply this formula. So, in your normal curve, should this have been a normal curve? If this is better for you to look at, this is your mean. This is your 1, 2, 3. Okay, now watch. Your mean goes here in the middle. We're going to add 21.1 for each of the standard deviations. Just kind of bear with me. So, 56.4. We're going to add another one. 21. 77.5, and I'm going to add them all. 99.6. Now we're going to go backwards. 14.2. Let's take another 21.1 off there. Negative 6.9. Let's take another 21.1 off there. Negative 28. Now, can you find me the values that are plus or minus 2 standard deviations away from the mean? Negative 6.9 to what number?
77.5.
77.5. So Chebyshev says this. Take your mean, add 2 standard deviations, you get 77.5. Take your mean, subtract 2 standard deviations, you get negative 6.9. This works, or this works. Then just watch this. So therefore, I could do this either way, right? And find out these values. Problem is this. Was this a normal curve? No. So it does not fit these percentages. So to figure out what percentage is plus or minus 2, I have to apply Chebyshev's formula. So now, k equals 2, I plug my 2 in here. This gives me 75%. Instead of adding up these percents and getting 95%, this says this doesn't fit your normal curve. So from negative 6.9 to 77.5 covers 75% of your data. Okay? But we're just going to adjust this because there's no age, negative 6.9. So we're going to make it from 0 to 77.5. Covers 75% of our data. So they see kind of over here, if we kind of look from 0 to, if we estimated here, wouldn't the bulk of our data be here, according to this skew? We see this graph. We can actually see where the skew is. Sometimes you can't see where the skew is. So somehow we came up with this theorem to help get around the problem that it doesn't fit your normal curve.
So we'll never put the negative 6.9, always be 0.
Will always be, well, in this case, 0, because you can't have a negative age.
Okay.
In most cases, you have to start at the 0 because you're usually counting something or...
So that's what it depends on what it's talking about.
Right.
But
And in most cases, it will be 0 because we usually don't have a negative anything really. Yeah, anything like that will always be starting at 0. So what if I said, how much data did he cover with 3 standard deviations away from his mean? Nick?
negative 28 to 98.6.
So you would say negative 28 to 99.6, so we're going to adjust this to 0, right?
Yes. And then you have to do a formula with 3.
Good. And then we'll do his formula with a 3 in here.
This one.
So this becomes 1 over 9, so this becomes 8/9, which is 88.9%. So 88.9% of the data, you are guaranteed to fall between 0 and 99.6. Could it be more? Could it be less? It could be. Well, it won't be less, but he's saying at least it will be 89.6. It could be more, but at least you covered almost 89% of your data. And chances are you probably covered 100%, but you can't get any more exact because doesn't follow a normal curve, nor does it follow a constant skew. The skew changes all the time. So he only has a way to approximate. And you can't do 1 because 1 says this. Gives you 1 minus 1, which gives you 0%. He says it's too close for me to do a 1. Okay? Does that make sense? All right. This is the only time we look at something that's not normal. The rest of the time we stay with your normal sets. Now, do I just have like 2 minutes? 5, okay. All right. For the rest of this is easy. You could do a table like we did the other day, and take your square of your means. You know how we did the columns? We took the mean, we took the difference, and then we squared it. Well, this is saying, what if you have a frequency? So it's saying, take your sum of your means, take your means, and multiply it by the frequency, and then take the sum of all of that. We're not going to do that table. All we're going to do is use your calculator for this. So we're going to say, whenever you have group data, you're going to do this. You're going to put this in your L1. You're going to put this in your L2, just like you normally do. And you're going to do a 1 var stat, L1, L2. And then you can find your means and your population standard deviation or your sample standard deviation. But you have to say L1, L2, which you guys know how to do. We're not going to do the table for that.
What are we?
If you need to have a frequency in your chart, like so far we only have L1 numbers,
Yeah.
you just use your L1, L2.
Yeah.
That's it. And your mean and your standard deviations all come out the same.
So that's what.
Yep. Now, and remember when we had the intervals? You can't put 0 to 99 in your L1, so we used
The midpoint.
midpoints. So therefore, your midpoints would be your L1, and this would be your L2. That I'm not making you do any different. And that was it. Oh, we'll have to hit this part tomorrow. Tomorrow,